Okay, so shingles. A research doctor has discovered a new ointment and she believes will be more effective than current medication in treatment of shingles. 8 patients have volunteered to participate. You were a statistician hired to consult to help design a completely randomized experiment. Okay, so describe how you will conduct this experiment. Okay, so we're comparing a new medication to an old medication. Okay, so what we're going to do is we have 8 volunteers. Okay, and we're going to randomly assign 4 of them to get the new treatment and 4 to get the old. So that's random. And then we will compare the results. Okay, these are the subjects. Okay, how will we randomly assign them? Well, give each patient a number 1 through 8. Randomly select the first 4, ignoring repeats, to get the new, and the other 4 to get the old. Okay. So what do we have? We have a factor here. Okay. So we have one factor here. We have medication. Okay. At 2 levels, new and old. So we have 2 treatments. And how are we going to compare? Well, we can say time to heal, percentage of the disease that's healed. Okay, either one. All right, so in the second question, we got a random number table, and we had to randomly select how we're going to assign the subjects to treatment. So here's what I'm going to do. A equals 1, B equals 2. They said that each patient has their last name ends in a letter from A to H. So I'm going to assign each of the first letters of their last names. So we're going to ignore 0 and 9. Okay? And then I'm going to go to this. So I got to assign the first 4, which was part of my experiment. So let's see. D goes to the new treatment. A goes to the new treatment. Ignore 0. Ignore 9. 8, which is H, goes to the new treatment. Ignore 1. Ignore 8. And then 3 is C. So we had D, A, H, and C. So those are the 4 that I would assign. Okay. I also forgot to mention when we designed this, not only would we ignore 0 and 9, but we'd also ignore repeats. Okay, we want to ignore repeats. Okay. And then, can we make the experiment double blind? Yeah. Well, here's what we would do. We would package the medicine in the same kind of container so that the administrator can't tell which one they're getting, neither can the patients. And then we would not tell the evaluators who got what. So we blinded the subjects, the administrators, and the evaluators. No one knows who got the new one or who got the old one, so that experiment would be double blind. And then D says the initial experiment revealed that males and females may respond differently, further testing the drug's effectiveness. What changes in your first design, if any, would you make? Well, the very first thing we would do is we would block. So we have our 8 volunteers. Okay. And then it doesn't tell us that half. It doesn't tell us how many there are. Okay, so we don't know, but the first thing we would do is divide them into males and females. And then we would randomly assign half to the new, half to the old. So that would be random. And this would be half new, and then half old. And that would be random. compare with the new locks, and we would see if it worked. Maybe the new ointment works very well for males, but there's no difference for females, so then we would market this only for males. Okay, so that's that question.